Once I started down that long road of trying to map these windings, I ran into a few issues with my previous drawings. The issue right here is that there is no I winding on this red phase. There is an H winding. So I had to redraw it. So that is shown. So there's only 2 jumper wires between slots 9 and 15 instead of 4. So to try to make a visual representation of this, if I turn off the power windings for the red phase, turn on the power windings for the blue phase, you notice the blue phase does have an I winding, but it doesn't have an H winding. So once again, there's only 2 wires. It's for the red phase. Up here, we only have 2 wires for the blue phase. So by removing 1 winding on each one of these phases, it was obvious how the phases actually work. A much better understanding has been gained. So this cluster of 4 windings jumpers over to this cluster of 4 windings, and let's take a look at why that works. If we turn on the armature layer, you can see that while the armature is cutting 3, which is doing nothing, it's also cutting 15, which is doing something in the opposite polarity because of the opposite faces of the rotor. So I tried to put this into a drawing, and this is what I came up with. First of all, we'll take a look at what I'm talking about. This winding is missing, right? Because we're only going to do 60 hertz. But notice the blue phase has 7 coils, and the red phase has 7 coils. But you notice the red label is at slot 22, whereas the blue label is at slot 10. Since these are in parallel slots, the phases they have to be in parallel. In other words, they're not opposing. The phases are in parallel. It's just how we connect to them makes them 180 degrees out of phase. It's the connection that does it, not where the windings are located in the slots. So that was very difficult to come up with initially, but I understand it now. So if we go take a look at our stator map, I've started trying to draw a stator map. I'm trying to put a circular rotation into a horizontal linear rotation in this drawing. So here, up here we have the blue coils, down here we have the red coils. And the bearing end is right here, and the bearing end of the stator is right here. So this note here says fold this drawing along this orange dotted line, then fold the red underneath the blue. And that's what we really have here. We have the red and the blue phases actually in parallel, generating the same phase voltage, but we're tapping them at different ends, which makes it look to the user like the phases are 180 degrees out of phase, when in fact they are in phase. It's just the connectivity that makes it appear that the 2 phases are 180 degrees out of phase. So I've been beating this dead horse for a while, and once you understand that, everything becomes more clear. So these tools are necessary to understand what's really going on here. These tools are going to be used to determine the connectivity of all these coils, so that the coils actually work together, and the generator works when I rewind the coils using this map. So right now all I'll have on the map is the 8 coils. Should be 7 coils in each phase. But what I do have is the ability to show how the north face, the leading edge north face, always pulls current out of that bearing end of the stator. Doesn't matter whether it's red phase or blue phase, it always pulls current out of slot number 3 on that phase winding. And the same way with the south phase, will always force current into the bearing end of that stator. And also here, bearing end of the stator pushes current into it. So So with this understanding, we now go ahead and we can move this rotor and demonstrate how the current's flowing in these coils, because that's what needs to be understood in order to connect the coils properly. So what I've done, I've made this a group of items. I can now go ahead and, by setting up my options such that each horizontal displacement nudge is 50.55 inches, then this thing will move one winding pitch at a time. So I have this selected. I'm going to take my right arrow key. I'm going to step it to the next position. Notice now the leading edge is cutting these two equally, so they cancel out. So this leading edge is actually cutting that one. It's generating voltage with that one, current I should say. And this one right here, you notice these two are canceling out, so it's not doing anything. On the other phase, then it is cutting, well, these two are canceling out, but it's also cutting this H winding on both ends, so they're canceling out. So that's how we're going to use this. We're going to step this one winding at a time and determine which way the current's flowing, and that way we can tell which way to take this winding someplace else, wherever it has to go. So this whole lesson was in developing these tools so that we can actually do the mapping of the windings, showing how each winding connects to the adjacent winding, and keep all the currents happy so that it actually works. So this lesson is basically just creating new tools so that we can understand what this thing is doing, whether it's the blue phase or if it's the red phase. I need to relabel these so they have blue phase and red phase instead of just power windings. So a lot of effort went into changing these drawings, and now I'm ready to move on with the next video where we'll actually use these drawings to demonstrate how the current is flowing in all these coils, therefore how the coils have to be connected.